Okay, guys, so let's get started on chapter 23 in your book. I'm working off problems on page 198 in your calculations textbook. And this all has to do with our ratio and proportion calculations, which is a really, really fundamental part of being a pharmacy technician and also being a pharmacist. I took courses like this when I was in my first professional year, so my third year of pharmacy school. So this is stuff that I'm certainly getting flashbacks to. Hopefully you have a better time understanding it than I did my first time around, but I eventually got it. I eventually was able to do it, and you can too. I absolutely believe it. So what do we have? We have a problem. A doctor orders 500 milligrams of a medication, 500 milligram dose of a specific medication. Doesn't matter what kind of medication it is. We just know that it's only available as a 1 gram per 2 milliliter solution. So how many milliliters do we need to make of this? How many milliliters of this solution do we need to have that 500 milligram dose? Well, firstly, you'll notice we have a little issue, and this can trip people up quite a bit. It's quite easy to trick people up with this. One of the order, the prescription is written in milligrams, and our medication is written in grams. So first thing, we immediately want to either change the grams to milligrams or change the milligrams to grams. So I decide I like to do 1 gram is equal to 1,000 milligrams. So our stock solution then has the ratio of 1,000 milligrams to 2 milliliters. See, this makes it a little bit easier to work with. And these two things, they're exactly the same. I haven't changed the concentration. I haven't changed the value of anything. It's just transposing. Instead of grams, I'm just counting the solution as 1,000 milligrams because those milligrams are going to be easier to work with since our final dosage is supposed to be in milligrams. So I'm going to continue going up here. So our stock solution has that ratio, that 1,000 milligrams over 2 milliliters. So then it becomes quite an easy problem, right? We have our proportion that we can set up, 1,000 milligrams over 2 milliliters. So this is just our stock solution. And now we want for one dose, 500 milligrams. And what do we want to find out? We want to find out how many milliliters are needed. So as we set it up, we need X milliliters to get that 500 milligrams. Then it just becomes a matter of cross multiplying. So we multiply 1,000 times X, 1,000X, 500 times 2 is 1,000. And this problem turns out it's going to be really, really nice and easy. So divide to solve for X, and you get 1 milliliter needed. So that is 1 milliliter of our stock solution is necessary to get the patient that 500 milligram dose of medication. Now, you can also use dimensional analysis for this. I understand that this chapter is for ratio and proportions, but I'll show you how the dimensional analysis method of it too, because that way you can cancel out all of those nasty conversion factors all in one go. So we have 1 gram for 2 milliliters, that's our solution. We want to change those grams to milligrams, so we set it up as 1,000 milligrams is equivalent to 1 gram. And then we want to find out how many of those milliliters or how many milligrams go into 500 milligrams. And that equals X milliliters. So all you do with dimensional analysis is you cancel out your separate, you end up canceling out your units. So if there's a G on the top, a gram on the top, and a gram on the bottom, they cancel out. The milligram on the top, milligram on the bottom, they cancel out. And all that's left in our problem is milliliters. So we know that our solution because it hasn't canceled out. There's no milliliter on top or anything to cancel out that milliliter on the bottom. So all we have to do is multiply 1/2 times 1,000 times 1/500. When you multiply all that out, it all cancels to 1 milliliter needed. So we get the same answer, just through a slightly different method. Now, the other thing that we can do, we have another problem. We're going to try and approach a problem with another pharmacy term in it. We have problem 23.3 or 23-3. It's an example problem in your chapter 23, again on page 198. We have a physician orders 367.5 milligrams of medication, and he's ordering TID. He's ordering a TID. The drug itself is available in 35 milligrams per 1 milliliter. So what is the total of milliliters? How many milliliters should the patient receive? You'll see I abbreviate patient, PT. Should the patient receive in 24 hours? So we need to find out how many milliliters should the patient receive in 24 hours if the drug itself only comes in 35 milligrams per 1 milliliter, or 35 milligrams per milliliter, and the physician wants 367.5 milligrams. Well, this is actually a lot easier than it looks, because we just have to work with the information that we're given. So we have 35 milligrams of the drug, and that is over 1 milliliter of solution, because that's what we have in stock, right? So all we have to do is figure out X milliliters of solution, because that's what we want to find. X milliliters of solution would be used to get a dose of 367.5 milligrams. So cross multiply like always. 367.5 times 1 is 367.5 again. And 35x, you divide that by 35, divide it by 35. You end up getting X equals 10.5 milliliters. Well, then we're done, right? Wrong. Let's look at the problem again. Physician orders 367.5 milligrams of drugs to be given TID. TID, that's 3 times per day. So what we just calculated down here is 1 dose, right? This is 1 dose of that medication. And you can bet that this would be one of the answers, especially in a multiple choice question on the PTCD exam. They're going to try and trip you up by saying, oh, I made the 10.5 milliliters. That must be it. That's absolutely it. It's got to be. That's got to be what it is. So we have to remember, well, if they're taking it 3 times a day, how many doses are they taking per day in a 24-hour period? And the answer is they're taking 3 doses. So all you have to do to get the actual answer to the problem is multiply 10.5 times 3, and that equals the total dose a day that they're getting. The total milliliters per day that they're getting is 31.5 milliliters, and that's per day because they're getting 3 doses per day. So that is that with ratios and proportions calculations for chapter 23. As always, if you have any questions, feel free to follow up. Thank you.